So we'll start with problems for the chapter mathematical reasoning, and we'll look at the first question right away. It says, which of the following mathematical statements is correct? So we have to check the validity of all these statements. So let's begin evaluating them one by one.
Okay. First of all, we go to the question, today is a windy day.
Right.
And we judge whether the question is a mathematical statement or not.
Okay.
So what do you think? Directly we come to the conclusion that this is not a mathematical statement.
Okay.
Now what is the reason behind it? Look at this. You have a today here, right?
Right.
So today is a time factor.
Okay.
Any mathematical statement cannot include a time factor with it.
Right.
You understand the reason why, right?
Because it changes.
It changes with time.
Okay.
Basically. Now, I think the first part is clear. Right. Let's move on to the second part. How many sides are there in a hexagon?
Okay.
Now, you look at the question. Is it giving you any valid information?
Okay.
If we look at the question, it is actually it's simply a question, right?
Right.
It's asking you something. Mm-hmm. So any statement cannot be said mathematical if it is a question.
Right.
Okay. So since we have a question mark over here,
okay,
we cannot call it a mathematical statement.
Okay. So
similarly, if you remember the theory, so any statement which has a question mark or an exclamation mark cannot be called a mathematical statement.
Correct. So these are basic definitions of a mathematical statement which you have to apply here. Okay. So we'll look at C and D now.
Look at the C part. The cube of an even number is always odd.
Right.
Now once you look at the question and all of a sudden you realize that this is a false statement.
Okay.
Right. So you may be in a situation to call it that it is not a mathematical statement, right?
Right.
But this is wrong.
Okay.
Theoretically it is a mathematical statement.
Exactly, because
any statement, a mathematical statement is one which is either true or false, but not both.
Okay.
Like it should not be a paradox. That's it.
Okay.
Okay.
So it doesn't have to be correct to be a statement.
Exactly.
Okay.
It is mathematically false, but it is a mathematical statement.
Right.
Fine. Let's move to the D part. The product of 3 and 7 is greater than 15.
Okay.
So let's directly go to this. 3 into 7 is 21, which is obviously greater than 15. So by any means, there is a mathematical statement because it does not include any of the previous conditions we have included.
Okay.
Right?
And we have also checked that it is true, but that's irrelevant because all we had to do was check whether it's a statement or not.
Exactly.
Okay. So this was a question based on basic definitions of what a mathematical statement is.
Yeah.
So this was problem 1. So it says we have to find the negation of the following statements. So this is again a practice kind of a question.
Yeah.
And so let's work through it actually.
Okay. See, basically first of all, there's just a revision of what negation actually is. Negation means the negative of the statement given, right?
Correct.
Like whatever statement is there, you have to write the false of the statement.
Right.
So if I've taken very simple examples for this, like if all triangles are not equilateral triangles,
right?
Okay, so we would be writing that all triangles are equilateral triangles, right? Okay, let's move to the B part.
Right.
Every number is a natural number.
Right.
Okay, so just the reverse of it, just the negative of it, that every number is a natural number, leave it, every number is not a natural number.
Correct.
That is a negative of it.
Right.
That's all.
So this is how you write negation of statements. So wherever you see a not, the not has to be removed, and wherever you see a composite statement, actually, for example, here every number, this is what we are talking about, and we are asserting this fact about that those numbers, right?
Yeah.
So we have to insert a number not there. Right?
Exactly.
So
and it's not only it's not important to just write not.
Okay.
For example, if I say all triangles are equilateral triangles, so I can say it is false that all triangles are equilateral triangles.
So there we come to know that negation can either be implied or it can be explicit, and we'll have to check in both cases.
Exactly.
Okay. So this was problem 2, and we'll move on to the third one now.
Okay.
Yeah. So problem 3 asks us to find the component statements of the following compound statements, and the first statement is all integers are positive and negative, and the second statement is 11 is both an odd and a prime number. So
okay, so first of all we need to see that what compound statements basically are. Okay, so let's look at what is a compound statement. Compound statement is a combination of one or two component statements, right?
Correct.
So basically that is a combination. So first of all, let's look at the first part.
Right.
All integers are positive and negative. Okay, so this statement gives you two pieces of information, right?
Right.
The first one is all integers are positive. Okay, I mark it like this. All integers are positive, and the second piece of information is all integers are negative. Okay, so these are the two component statements of the compound statement. Now let's move on to the second part.
Right.
Okay, the second part says 11 is both an odd and a prime number.
Correct.
Okay, now you tell me which are the two main information that we get from here.
Okay, so it says that 11 is an odd number and that 11 is a prime number.
Exactly. So first part would be 11 is an odd number. Okay, the second part would be 11 is a prime number.
Correct.
Yeah.
So again, we have to check, we have to find out the component statement. So we see how we have to break them. Usually they are separated by, the
And or connecting
and or.
words.
Exactly, those connecting words are what you have to look for. So we'll move on to the next one. This was a fairly basic problem.
Yeah.
So the next one says that we have to identify the connecting words, in fact, and break them into component statements. So, okay, so how do we start with this?
Okay, first of all, I've written this, right? What are connecting words? The basic doubt comes here, like what connecting words are.
Right.
So, for example, you go to the first part, okay?
Okay.
Square of an integer is positive or negative.
Okay.
This is a compound statement basically made up of two component statements. Okay. What are the component statements? Square of an integer is positive.
Right.
Square of an integer is negative.
Exactly.
Okay. So the connecting word is the word that is joining the two statements. So what is the connecting word here? It is or.
Or.
And what are the compound statements? Square of an integer is positive. Statement 1, the component statement.
Right.
And the second statement is square of an integer is negative.
Okay.
Okay.
Right.
Clear.
Fine.
Let's move on to the second part. A line is straight and extends infinitely in both the directions. Okay. So here, look at the two pieces of information. A line is straight.
Right.
And a line extends infinitely in both the directions.
Correct.
So for the first
connecting
part,
word here is and. obviously.
the first part it was or, here it is and.
Right.
So what is the connecting word? It's and.
Right.
And the component statements are a line is straight and a line extends infinitely in both the directions.
Right. At this point, I'd like everybody to see how in language, the information can be distributed across and you don't mention the subject again, but it is implied that the subject is there. Okay.
Yeah.
So this was again problem
Number 4.
Okay. So let's move on to the next one. In fact, and this is problem 5 here.
Yeah.
And we need to two lines intersect at a point or are parallel. So we are asked if both can happen together.
Okay. So basically, what is asked over here is whether this or is inclusive or exclusive.
Right.
Okay. So for this or to be, first of all, let's understand what is an inclusive or and an exclusive or.
Okay.
Okay. What does exclusive mean? Exclusive means the two things cannot happen together.
Right.
If a line has a connecting word, then the two statements that the line has to imply,
Right.
both the statements, if both the statements are true, that or is inclusive.
Okay.
And if both cannot be true at the same time, then it is exclusive.
Exactly.
For example, if I say 2 is an odd number or an even number.
Right.
Okay. So this is an exclusive or because
Okay.
2 cannot be odd and even at the same time, right?
Right.
Okay. So let's move on. So basically, that's why I've said that you just need to apply some common sense over here.
Okay.
Let's move on to the first part. Two lines intersect at a point
Right.
or are parallel.
Okay.
Now just think about it that if there are two lines which are parallel, can they ever intersect each other at a point? No. The answer is no, right?
Okay.
So that is why the or here is exclusive.
Right.
Right? Okay. Let's move to the B part. The B part says all integers are positive or negative.
Right.
Okay. So all integers are positive or negative is once again an exclusive or.
Right.
Okay. And the same reason being exclusive, what does exclusive imply? Exclusive implies that either
Exactly. In fact, the word either,
Yeah.
the best way to check for exclusive or is to, use the word either. Because either is never used with inclusive or.
Exactly.
Right. So as soon as you see an or and you can't be sure whether it's, inclusive or exclusive, you just try to use the word either and that will straight away tell you whether it is an exclusive or not.
Clear. So
Okay.
just break the two component statements and check each of them.
Right.
Huh.
So again, this was problem 5. Problem 6 here. we have to identify the quantifier in each statement. Okay, so what exactly is a quantifier?
Okay, so quantifiers we've already taught. Let me not go into the details of it
Right.
because we've already gone through the theory.
Okay.
The two quantifiers which we had studied are, just let me revise that. One was there exist and the other was for all.
Right.
Okay, what does there exist mean? There exist necessarily implies for some values.
Right.
Okay, there exist an x for some values of y.
Okay.
Okay, and what does for all mean? For all means for all values of x or for all values of y.
Right.
Okay, so basically you do not have to even apply a common sense, your common
Exactly.
sense over here.
Right.
You have a statement and you have to think where the quantifier is.
Okay.
For example, the first statement here says there exists a number which is equal to its square.
Right.
Now since we have a quantifier here, there exists, so the quantifier is there exists.
Okay.
As simple as that.
Right.
Okay.
And again, in
Huh.
B part we have for every real number.
For every real number. So
Right.
basically you
For
do
all
not
real numbers.
for all real numbers. So
Exactly.
basically you do not have to even apply common sense. Just remember the basic sense of a quantifier.
Exactly. So basically you have to just remember what the word quantifier means. That is all there is, and very complicated modification of such questions. They're just there. Okay. So moving on to problem 7. It
Okay.
says the contrapositive and the converse of the following statements have to be found. Okay.
Okay.
So let's actually start with what contrapositive and converse is, and let's revise that again.
Okay. So first of all, let's look into what contrapositive is. Okay. Contrapositive means, like for example, you get a statement,
Right.
you take the negation of the statement and you take the same meaning of the statement.
Right.
Like for example, if I say 2 is an even number and let's say 2 is a multiple of 2 itself.
Correct.
Okay, so you will say 2 is not an even number and it is not a multiple of itself.
Right.
Okay, so just the negation of it and for the complete statement.
Okay.
For example, if we say x is an even number, implies that x is divisible by 4.
Right.
What would be the contrapositive of it? If x is not divisible by 4, then x is not an even number.
Okay. So the point here, another point to note here is that we go backwards in
we
contrapositive.
do go backwards here. Okay.
And it makes sense. You will see how it makes sense when we start proving some things later in later problems.
Huh.
Actually.
And contrapositive and converse, the best thing you need to, the most important thing in fact you need to remember is, like, always start with the word if.
Okay.
Like if whatever statement is given, just think what can happen. Like
Right.
here x is an even number.
Okay.
Implies that x is divisible by 4.
Right.
So what are the two statements? You just have to link them with if.
Exactly.
Okay.
So in contrapositive, what you do is you start from the end and you move backwards and you apply negation to each of the elements.
Huh.
In converse, what you do is you do nothing. You just start from the back and apply or implicit applications of like if x implies y, you start from y.
Exactly.
And y implies x is your converse.
Exactly.
Okay.
So what would be the converse for this statement? If x is divisible by 4, then x is an even number.
Correct. So
Very
this was
good.
part A, and let's look at the second part now.
Okay. The second part says if a triangle is equilateral, it is isosceles.
So I'll
Okay.
just go ahead and do this, and we can see whether I'm correct or not.
Very
if a
nice.
triangle is equilateral, it is isosceles. So the contrapositive would be if a triangle is not isosceles, it is not equilateral.
Very nice.
Okay, and the converse hence should be if a triangle is isosceles, then it has to be a equilateral triangle.
Yeah.
Equilateral triangle.
Good.
Exactly. So now you can work out how we are exactly doing this. It is just to do with reversing the structure and applying negations or not applying negations in cases of converse. So this was how we write contrapositive and converse, and this was problem 7. We'll look at the 8th one now. So now that we have verified our basics, we'll move on to more serious problems. So now on, all the problems that we'll discuss have appeared in previous year JEE question papers. So this is problem 8. It says the statement P implies brackets Q implies P is equivalent to what? So in such questions, the best approach is to begin from what we think is the most likely answer, and from then on verify the validity of those statements.
Exactly.
Okay.
So for all these questions, we have a simple basic step. Okay. For every imply, we should always convert the implies. Okay.
Right.
Matlab basically it means this ki, for example, we have implies over here and implies over here.
Okay.
Okay. So break this statement in such a way that these implies, matlab these statements are no more there.
Right.
Okay. So let's move on. For example, okay, just I'll scroll it down a bit.
Okay.
Okay. P implies, what is the statement? P implies Q implies P.
Right.
Right. Okay. So first of all, break this statement into negation of P or Q implies P.
Okay.
We have done this earlier, okay?
Right.
Like this has been already taught if you go to the theory and the
Okay.
truth tables for all the parts, okay? Now further the same thing you have to do with this.
Right.
Whatever we have done over here.
So we start breaking them from the outside and then move inwards.
Exactly.
Okay.
So not P or not Q or P.
Okay.
Okay, the same thing. Whatever we have done in the first step, we are doing it in the second step.
Right.
Okay. Now look at this carefully. We can just reverse this P and Q over here because of the or.
Right.
Because all of these statements are like, if one of the statement is true, then the statement is true.
Right.
Okay. So we just write over here not Q or P or not P.
Right.
Are you clear till here?
Okay.
Because we've shifted over here, and since it's or, so P or
Exactly.
not
So
P.
since
Okay.
it's all of ours, so we don't need to worry about the order of the
Exactly.
statements. Correct.
Okay. Now look at this. P or not P.
Okay.
This statement is always true.
Right.
Do you believe that?
Exactly.
Okay.
So it will either be true or its negation will be true.
Huh.
Right.
Okay. And if I write this statement, the negation of Q or true, can we say that this statement is also always true?
Okay. Because
Okay.
yeah.
Huh. So what does this imply? If you remember, there is a term called tautology, right? So this statement is basically nothing but a tautology. Why? Because the statement is always true even though any of them is true or false.
Right.
Doesn't matter.
Okay.
Right. Also, let's just move on and let's see that. Fine. So this implies that P implies Q implies P
Right.
is equivalent to P implies P or Q.
Right.
Okay. What is the reason behind this? Because this can be written as not the negation of P or P or Q.
Right.
Okay. And now we've come again to the similar steps. Whatever we had done before.
Okay.
So we have come to one of the steps of the previous part.
So
Whatever
that
we had
means
done.
obviously they're both the same. Okay.
So that's why from here we can conclude that whatever the answer what I have just marked over
Okay,
here.
so this was a question in which we had to verify whether which of these following statements is equivalent to the given statement.
Huh.
So how we proceeded to do it was we took the given statement and we tried to simplify it as much as we could.
Huh.
And so we reached a tautology. We reached the conclusion that it is a tautology.
Huh.
And then after that, what we did was we evaluated. We looked at the expressions which were given in the options, and we saw that one of the options after just one transformation resulted in one of the expressions which was a part of one of the steps we took.
Yeah.
Okay. So as soon as we
one
reach,
mistake that people generally commit here is
Okay.
they go to the true sense of the question.
Exactly.
Like P is a true statement, then what happens to Q and P? So that may be lengthy in a multiple choice question.
Okay.
Right. So always try to go from the question, whatever the question is over here.
Right.
You go and deduce it in steps. And whenever you'll go in steps now, you'll always realize that one of the parts in the question
will either be one of the steps or it will merge into one of those steps.
Exactly.
Right. So as soon as we find any option which is merging into one of those steps, since this is a single answer question,
Yeah.
we automatically know that that we have to just check that and move on.
Yeah.
So because saving time is also pretty important, especially in
Exactly.
these questions, because when people set question papers, they don't want you to spend time in this, in the sense that they want you to spend that time somewhere else, right?
Exactly.
And those questions will be complicated and lengthy, so it's best to get done with these questions faster.
Yeah.
That is why you should always remember these little tricks.
And the common steps too.
Okay, so
Yeah.
this was problem 8.